Okay, we'll start the session. Good morning, everyone. Once again, welcoming you all to another session in our Train the Trainer series. As many of you are return participants, you know that this is the seventh session in the series and Cloud Tech for the first time. And this is on popular demand again on the feedback that we have received over the last few sessions that we have taken up Cloud Tech. And this will be the first session in the series. We have two more sessions planned this month. We will send out the invite for registration for that. Today, we are going to have a session on cloud architecture, focusing on microservices, serverless, and event-driven models. And we have with us Srikanth. He's the head of technology office at IDP Digital Campus, who's in EduTech. So all the three topics that Srikanth is going to dive into today are his favorite areas of expertise, and he's over 20 years of experience in this area. And he's also worked on CRM and with tech adapting, he's also interested in AI and he's a constant learner. So I think he will add a lot of value to us in this session today. Over to you, Srikanth. During the session, if you think that, you know, at any point you want to pause and take questions or anything like that, you can feel free. Likewise, to the participants, in any time that you have any questions, please drop in your questions in the chat box or the Q&A, and Srikanth can answer them either between the session or at the end of the session. Feel free to keep it interactive. In case you want to raise your hands and ask a question also, please, you can do the same. Thank you. Thank you for joining us today, Srikanth. Over to you.
Thank you, Kavya. I'll quickly share my screen and then probably start from there. And let me know if it is all coming okay, Kavya.
Yes, we can see your screen now.
It's all good. And is the voice coming out clearly?
Yes, Srikanth.
Good. Thank you. Good morning and happy Friday, everyone. It's an honor. Thanks for Kavya organizing this session to interact with you. We're going to explore the transformative world as we've been talking about the cloud architecture, and which is one of the modern software architecture practices and the styles that we are going to discuss today, which is into microservices, event-driven, and the serverless architecture. And if you have noticed my background, the image that I have said, I would like you to connect to the smart city. I think we've been talking a lot about this in India as well these days. So each of the independent parts that operate together and seamless and real-time functioning of a smart city. Imagine you are in that bustling city, say in Coimbatore, and each part of the city having got the traffic lights, trains, the food delivery services, and healthcare systems. They all run on its own independent entity. This is like microservices. Just for you to get connected to that metaphor, think them as all individual microservices. And each of them would work autonomously by themselves. They can able to function on its own. But when needed, they can communicate with each other. And when we dive next into another topic of event-driven architecture, then picture yourself a festive day where trains get delayed. And instantly the traffic control center adjusts the routes, the food delivery services reroute as well. And this is how event-driven works. So which is responding dynamically to real-time events without constant oversight. So just like our smart city in this case, is responding to that delay in a train and everything getting rerouted accordingly. And lastly, when we talk about serverless architecture, again, think about this, about Diwali that's upcoming. Instead of keeping the lights on 24/7, we only want to illuminate when the darkness sets in. This is serverless architecture. That system that scales up when triggered, allowing us to handle tasks with greater efficiency and lowering costs. So we don't have to keep it always on. We just switch it on when required. So just going with that metaphor of the smart city, we'll now deep dive a bit into each of these topics. And we got 1 hour set for the whole session. But so we will try to create as much as interactivity as possible within this session. But each of the topics by themselves would require a longer duration than 1 hour, right? So we'll see how much we could make it interactive and give you some real world examples of how you can actually implement each of these architecture patterns and styles. So I'd like to start with this particular quote from Werner Vogels, who is a CTO of Amazon. You would have been hearing about him a whole lot. So evolving architecture. So today we're talking about microservices architecture, and many of you in the past would have also been associated with where you have created systems that could have been monolithic, right? And when we actually go back and talk to our next generation software engineers who are coming into the real world, we need to set that mindset for them. And this is what I also keep cultivating that in our teams is we need to revisit our architectures with an open mind. So whether it is a monolithics or microservices, and when it says we all will be dinosaurs someday, that means we will be extincting. So it's not a religion, so it's a strategy. So keep setting this mindset for our people, our kids, whom you are teaching back, that we'll have to revisit architecture. With AI coming into the picture, the whole landscape is changing a whole lot very dynamically. So keep that in mind and think about this, right? What are those driving forces behind evolving system architecture? Though we're going to talk about microservices architecture, EDA, event-driven, and serverless, what is something that is going to be constant always and forces us to evolve with the system architecture? And if anyone disagrees, you can post it in the chat. There would be constant changing business requirements across the globe. And wouldn't have never heard about some of the requirements that would have come, even including take very recent hit in the market is Insta delivery of groceries. And all of these things come into picture and the requirements of the business are changing. Technology advancements, we just spoke about AI briefly, but there is so much of advancements happening across the globe in every field. And there are obviously, when all of this happens, there will be regulatory and compliance changes that kicks in, whether it could be related to privacy, the health compliance of the medical records, everything. There are regulatory to ensure that privacy of the humans are protected. All of these constantly keep changing. Security threats, without saying, every day we keep hearing a new security threat hitting. So we should be always be looking and evolving our system architecture so that we protect our systems, our businesses as such. And these are the constant 4 things that we keep looking at in the organization I work in. And microservices architecture, when we get into this, I think most of you would have already been familiar with microservice architecture, but put it in very simple terms. It is an approach, a design approach in the software development, where an application is structured as a small collection of independent services. So we said earlier of a smart city, there are autonomous services of a healthcare system, of a transport system, etc. So each of them can have multiple further breakdown of services within their organizations as well. So anything that is doing one specific thing would be a microservice. And when you define and design a microservice, we wanted you to consider that they have to be highly cohesive, that don't overload it with too many things, right? It does one thing, one very specific thing, a business function. So we'll deep dive or at least look into some use cases of how we actually design and implement a microservice. But think about these concepts and the definitions and the principles are very important, especially because getting it wrong in the beginning can have serious impacts on your whole technology landscape. And that might be that you'll never get benefits of doing a microservice architecture. And then there would have been situations where a previous monolithic application would have been performing better than a microservices architecture that you redefine. So always consider that and look at organizations like, and I'm not talking about any software organizations, like look at Netflix, Uber, and Amazon as a product organization. They all have mastered microservice architecture. They have got hundreds of services that operate while maintaining seamless user experience. If you've been using I think most of us use an Amazon app, what you see there is supported through hundreds of microservices behind them. And they all work very seamlessly. So this is where at the inception stage, you need to define it well. That is where the art lies in more than a skill. There is an art of creating microservices architectures within organizations. So each microservice, as I just said, is highly cohesive. That means does one business function, and they are loosely coupled. So we don't want a tight coupling, and a no coupling is also not doesn't work for an organization. So a loosely coupled is, as we said earlier, when there is a delay in the arrival of a train, we said there is an reaction to that by the food delivery service. They're rerouting their services. So they're all interacting, but they're not tightly coupled. The food delivery service can still operate without the railway network being on, and the vice versa as well. So when it comes to the actual technology in the implementation, they are services that can be deployed, they can be modified, and without impacting the overall system independently. So when we talk about the benefits, right? The benefits obviously are agility. So business these days needs a lot of agility from the technology teams. So you can have small focus teams who can build one microservice, build and manage one microservice. The code base is going to be very small because we just said it is going to do one business function. And you can have a mix of technologies. So you could have teams who are well versed with different technologies. So you could develop one microservice using Python, a microservice using Java, and you could also plug in a third-party microservices through APIs and still make it all work within the landscape. And fault isolation, as we said, one service going down will not directly impact the other service. And as we speak in the next session in the event-driven, we'll also look at how this fault isolation can be done further with event-driven architecture. Scalability, obviously, as we just said, some of the organizations like Netflix, Uber, Amazon has got hundreds of, and some of them scaling up to thousands of services. They can scale very well. And when we talk about serverless technologies at the end of this session, you would further can actually relate to how the scalability works when it comes to microservices architecture. And data isolation. So you want to keep the data protected and within the remits of one microservice. So you could always define it. And as we go into the next slides, we'll see how we define a data model. But microservices allows us to have that data isolation. Think of this back in a monolithic situation where you'll have to have all of this data into one schema, and all of the services sharing the same schema, different teams having conflicts of publishing the or promoting the code and also having access to the data. So we tried resolving a lot of these issues that we had in the previous conventional architecture. Microservice architecture breaks those things and makes it easier, giving us all of these benefits. So a lot theoretical there. And let's pick up very simple use case. And we're just going to go through slide by slide. And I want you to relate to how we are creating a microservice. And as you just said, this is not complex. This has to be simple. It's a microservice. It has to be simple, right? And what we picked up an use case here is a customer review service. Imagine you're getting a requirement from your business saying that in our website, we need our customers to provide feedback, reviews for our products. And also we have got moderators because not every review has to be just published as they put in. We want some moderators who can review those feedback that is being provided and approve or reject them so that they get published onto the website. There are powerful frameworks like domain-driven design. I'm just giving you some of these clues. We are not covering them in deep here. I would like you to take it back after this session. Look up for domain-driven design, which is a very powerful framework for defining microservices in a way that it ensures proper alignment within the business domain and guarantees that appropriate service boundaries. When I say service boundaries, as I said earlier, creation of that microservice at the inception stage is really important, and we might get it wrong. It's not end of the world. We might get it wrong, and practically we have done it, and we have got it wrong a couple of times as well. So there are two things that happens. Either we might make our microservice anemic. That means it doesn't really do any function really by itself. It's always dependent on another service, right? Or we might make it a very heavy loaded microservice. That means it is doing more than one defined function. And we have got it, all of these use cases in our real time as well. This is not just theoretical. So we have got those use cases. But what happens in that case, we'll need to refactor them. But going through some of the domain-driven design DDD principles, you can avoid some of these. And also there is learnings from the industry that you could see how to actually set some boundaries for your microservices. So set this, this is our requirement that we got from our business. And if you look at the center of this is the customer profile. When I say a profile is basically the basic profile details of our customers. Let it be a first name, last name, date of birth, etc. is our profile service. Then there are connected services like in customer making an inquiry is in an inquiry service. So each of the bubble, imagine that is a microservice, right? Search of all the products and works independently. You haven't connected that to the profile, but it could be connected to the products separately. I haven't shown the entire graph here. Events, again, there could be fairs, exhibitions, something happening for your organization. And then those are in the event. So the one highlighted in blue is our microservice that we are going to define and implement today. When I say implement, I'm not going to go into the code base at this point. It's a logical construct that I would show you. Okay, what's the step one? Step one is defining those responsibilities. We said define what that microservice should do. And we just said it has to manage customer reviews. That includes creation of a review, update of a review, deletion of a review, and a retrieval of a review. And equally, as a moderator, should be able to review those approvals, approve them or reject them. Very simple. That's confined responsibility of my microservice, which is called the customer review microservice. Now I go do a data model. And again, we're not deep diving into data modeling session today, but you can easily connect to what we're showing it on the screen here. There is a root entity or a table, if you see it as, is a review table, has got an ID, has got a customer ID, and got some of the product related information into it, a rating, comments, etc. And then we also got the customer's first name, last name, date of birth, etc. So very simple data model. And a review table is being at the center with the key details that we would require. Once you have got the data model, you would then define API specifications. So Open API, given a reference here, Open API specification, if you look into swagger.io specifications, this is what is Open API specification, which is a standard that we all use to create these REST APIs. So the first thing is we design APIs and then we implement APIs. So in this case, if you look at customers has got few APIs that they interact with our system with. So whenever they're creating a review, we use a post. And again, we're not good deep diving into all the API specifications here, but if look at this as how the client application would interact with our backend microservice. So our microservice is providing all of these APIs. And the client application, which you imagine an UI that has got for customers, your website. And in the website, when they click submit review, they write the feedback and click on submit. This is what the API that would be called underneath. So we define the API specifications for each of these methods. So there is a post for review. There's a get to get all the reviews of a specific product. We update a review, delete, and then equally for a moderator, we give them post for an approval and a post for a rejection. And this could be action APIs as such. And then in the step 4, and this is the modern way of doing it, right? So you can limit it yourself to say, I just need the API so that it is all within my service. But then imagine, as we just said, in an event-driven architecture, as we move into the next slide, probably you'll get more context of it. We also wanted to tell the outside world of what happened in our microservices, because our microservices are only doing one function. It probably has to let know other services to react for something when it is happening. So a review being created, a review being updated, a review deleted, approved, or rejected, wanted to let the outside world, when we say the outside world, is all the other microservices in the ecosystem needs to know what has happened to these reviews, right? And so that they can react to those events. And we'll go in detail about it. But in the series of steps that you are doing in designing a microservice, defining event specifications is one of the key things. But again, it's a choice. If an organization chooses to do event-driven architecture, this would become a mandatory thing, or it could be an optional. And as I said, you might stop at step 3, which is defining the APIs. And step 5 gets into implementation. So basically you can see, and there would be a lot of references. I just want to make a note that of using AWS components in this session. This is what we use at IDP. However, there would be equivalent components of these in Azure, in Google, GCP, and other cloud providers as well. But a lot of references will be here from AWS. So I'll just take a pause here. I can see a hand raised from Punita. Do you want to come off mute and ask the question?
Hi, Punita. We see that you have raised your hands a couple of times. If you have a question, feel free to ask. I've allowed you to speak up. Or in case anybody else has a question on microservice, please drop your questions or raise your hand. You can ask a question.
Okay, I'll take that as a no. Probably we'll look into the chat, Kavya, separately and see.
Sure. So there's a question what is VPC?
So that's virtual private cloud. This is Amazon virtual private cloud that as we talk here, we can do a separate session on the infrastructure. So so if you go get into AWS and create an account, you get an VPC created for you. So you get an AWS account, a region that you can select, and within that you get an virtual private cloud. So all of your deployments are protected within your VPC. So, and when we talk about serverless components, I'll talk about the shared responsibility model of the cloud as well. So, but at least for your question, it's an virtual private cloud. Any other questions, Kavya?
Yeah, just one more question. In simple terms, what microservice means? I think he has just covered that, but maybe if you can just give a one-liner on microservice.
Yeah, so in a service-oriented architecture, so microservice is one specific, simple service that does one business function, right? In this case, use case that we see, customer reviews are put into one microservice. A customer profile is put into one microservice. Events are in one microservice. So everything does one thing. So if you look at your Amazon app, for example, which you can closely relate to, your cart is a microservice, right? Anything that you add to your cart goes into your microservice. When you are doing a product search comes from another microservice. So each of the interactions that you do are supported by hundreds of microservices behind the scene. So they're all individual independent components. Technically speaking, from a development perspective, they could be well managed by one team and they can independently deploy it without impacting the whole ecosystem. So they have got the control of changing, updating, and doing any of the APIs update or anything that is related to that microservice independently themselves.
Okay.
Okay, so looking at the time, then probably we'll move on to just to conclude from a microservices. This is way back in 2002 and we are now in 2024. And this is what Jeff Bezos from Amazon, and that time when there is not even AWS that has born, it's just Amazon at that point. And he's mandated to have ensure that everything they create is through like a microservices architecture. That means the only communication allowed is service interface. That means all through APIs over the network. And just not to fear anyone, but he's sent it out saying that anyone who doesn't do this will be fired. And so imagine we are still embracing modern software architecture with microservices. So even 20 years later, it still is a good service architecture that we can rely on. But again, best practices, implementation, lessons learned are key things that we need to know, and the technologies that are advancing in this area to ensure that we define and design our microservices appropriately. Said that, I would now take time to go into event-driven architecture. This is very close to my passion, event-driven architecture. And event thinking is something that I keep talking to our teams internally, whether it is our architecture teams, our engineering teams, our product management teams. Getting that event thinking is very essential in this current real-time world. So this was something that we started our journey 5 years before in 2019, where we were earlier just doing hosting on AWS, and we haven't thought much about events, what events means as such, right? And many of you probably would be in a similar situation today, and some of you have been hearing about this. And we just spoke about in the previous metaphor around the smart cities, how things can interact and react to certain events. And this is what is happening in the last several years. This is a revolution that is happening in the industry. Organizations must become real time, and for them to become a real time, they must be event driven. This is an event thinking, but the questions that comes is, what is an event? And I could ask this if it was in a physical session, but I might be challenging doing it in a virtual thing. But let me put it in very simple terms. There are three types of events we could categorize this, and look at this as an observation or some happening. So a customer walked into your store, or a student walked into your college. A customer in the previous use case, we said, submitted a product review. These are observations or something that is happening, and put it into a past tense, it has happened, right? And it could also be change in the state. So someone has submitted a review, but then it has also been approved. So it's the same review. Someone has reviewed and approved it. Or there is no response from our customer for 3 months, right? This is time-based now. So we're looking at, and every time each of these events are happening, there is something that you wanted to do about it, right? Those are what we meant events. And messages, right? Which is just as plain as saying, PSG announces a new engineering specialization course, a factory sale exhibition is announced for Trichy. So these are news that you get, and these are messages that are coming up. So when something like this happens, you wanted to something else to be done, right? So take in case of a customer walked into your store, what do you want to do? There are many opportunities for you, right? You might want to send them an welcome SMS saying that welcome to the store you have walked in. And we have seen where they have taken to the next level, where they do a facial recognition, they identify the customer, and then the ads that are displayed in the store are relevant to that customer and based on their preferences and choices. So they can very much relate to what is being displayed in the screen just in front of them. So the possibilities are so many, right? And all we're trying to do here is getting you to know the art of possibilities, not being very prescriptive of you can only do this X, Y, Z, right? Think about it. Event driven is so powerful that you can think about many possibilities as such. And there is another analogy as we talk about the smart cities, right? But maybe it's related to traffic accidents and things like that. But let me put forward to you, and imagine in the world of a smart city where there is an accident on the road, and your sensors on the car sends the signal saying that there's an accident and this precise location of the accident, and the message gets published to a cloud topic, and that is being received and subscribed by multiple entities. Like one could be the emergency entity, a hospital service, an ambulance service, and the traffic management service. So each of them getting this alerts can come and react to that event when it happened. So in this case, if it was a traditional older ways, the possibilities of saving a life could have been difficult, right? But imagine when you start doing this, and many of you would have been exploring things like IoT, right? And where you got sensors within your cars that can send these signals. So the messages that gets published. So each of the entities react to that event and come on time and save the life, right? So imagine again, it's so powerful if you start applying it to real life world and set some of those context for you. And when it comes to event-driven architecture, what does it mean? It is again a design pattern. We spoke about microservices, but then how does these microservices communicate with each other? They can talk to each other directly. It's a choice again, but is not a best practice. But because once you start getting a microservice dependent and talk to the other service in a request driven approach, you build a tight coupling. So that means the other service failing would also impact your service. So what can we do to make it a loosely coupled integration is by putting in event-driven architecture in this place. So what does it contain, right? What event-driven architecture contains is an producer, an event producer, an event broker, and a consumer. So keep these three things on top of your head, right? So when we say an event producer, is someone who publishes an event to the event broker. So in the previous use case that we have seen, the customer review microservice in that case is a producer of the event. And when we said that is a producer, the same service can also be a consumer of some other services events, which we'll see it in the upcoming slides. But in the previous use case, connecting to that, customer reviewed is an event. When a customer submitted and review created is what we called it there, is an event. And we published that to a topic. A topic is where multiple subscribers can subscribe to that message. Imagine like a very simple terms, a magazine or a newspaper. So you subscribe to a magazine. So the magazine is published by the publishing company, and there are multiple copies that gets distributed to every subscriber. So it's the same thing. So you got an event broker where you publish that message, and you got multiple consumers of that message who takes that message. And the consumer is basically, as we said, who needs to receive and process that event. So in our previous case, we said it's produced by the customer review service, and we publish it a topic. And then whoever are interested into that could be taking it. And taking the another analogy we took is the road accident scenario. In that case, it is the sensors that are publishing it to a cloud topic, and the consumers are emergency services, traffic management services, each of them being the consumers. Again, when it comes to the benefits, scalability, think about it, right? So you don't have a point-to-point integrations. So when you do a point-to-point integrations, is one system talking to another system directly, you create a lot of chattiness, and there is a high demand of the network, and scalability becomes a problem. So if there is a high volume or a load on your service, will definitely impact your downstream services that you have dependency on, or the other way around. If the other system is already been overloaded with a lot of traffic, your service trying to access that service would become a problem. So you make it loosely coupled through event-driven architecture, gets you that scalability. And exactly how things like Amazon app again, and and I'll show you some of our applications that we have built on event-driven architecture from IDP. We use event-driven architecture so that we decouple and sometimes have got loose coupling between services. So things that you could relate to very much is, again, like going back to Amazon's app. When you place an order, when the order is being accepted, there are multiple services that are triggered, and they're all running through EDA. So one that goes for payment, and then the one that goes for shipment, and then for the fulfillment. They're all separate services, separate teams working on each of these services, and they all interact with each other through these messaging, which are events. It brings a lot of resilience, so fault tolerance, agility, and real-time data processing, as we just spoke about. And it's an asynchronous communication. I think we spoke about not a request-driven model. The only thing to be considered here, event-driven architecture always has got eventual consistency. So that means it is not waiting on for a response, and there would be that minimal latency that you need to be aware of. So when you're designing your systems, and if you see it in any of our apps or in the Amazon apps or the Netflix, and who has got a lot of event-driven architecture behind, you don't even see that it is done that way. They're very seamless. So it's all about how you design the user experience, the whole journey in your applications. But otherwise, you need to be considerate of there is going to be eventual consistency. When I say eventual consistency, it is not updating your database through an API directly. So it's all through messaging. So someone is producing a message, is going into a topic, and someone is subscribing to it. There's going to be a hop and a latency that you will have to be considerate of. But what has been found statistically is that many of the user journeys that we have got can actually be on event-driven, asynchronous. It is not that our users want to wait for everything to be completed. You know the attention span that is being reducing day to day. People doesn't want to be on the side or on the page for every processing to happen. Let's say, for example, a document being uploaded. So when someone uploads the document, it's not that they want to wait for your backend process to systems to process that whole document, do an virus scanning, and then come back and say, oh, we have now accepted your document. All they wanted to see is whether you have got the document as soon as they uploaded, and they're okay for them to receive a message. And these are research statistics that says that users are okay and are very comfortable of doing asynchronous communications. Again, they are very basics of system design and considering user experience as well. So as we speak about some of the challenges we had uh, practically is, if you don't onboard your UX user experience teams onto how you're doing microservices and event-driven architecture, is a recipe for failure, because their thinking could be it is very synchronous, real time, having data access as soon as they go to the next screen. But if you design it to be event driven, it has to be done differently, whether you want to use WebSockets or polling or any of the techniques that you want to do. So bring them on board. And again, like as you teach this to the next generation, having that collective design sessions, co-designing them would give you a lot of benefit. Similar to what we've done with the microservices, now let's look at an use case here where we're talking about microservices with the request driven. So we earlier said about a customer review service. So look at this simple diagram that shows an user submits a review, which goes into a customer review service. But then we wanted to look at the age of the customer, right? And we wanted to return an error if age is less than 21 for some reason. That's the validation we have put in, not to go into detail of why it is 21, but now the customer review service has got a dependency on the customer profile service, because the date of birth is available in the customer profile service. If you'd have seen the data model that we shown earlier, there was a review service and there was a customer profile service, and the customer profile is where the date of birth exists. Now, in a typical microservices request driven architecture, what if the customer profile service goes down, right? And if that happens, your customer review service cannot work, because it would ultimately return 500 error back to the website saying that service is unavailable, because it got a dependency. Though customer review service is still working up, available, it is not able to operate. So which breaks the actual purpose of having microservices. That means they need to be autonomous, they need to be fault isolated. Here, we actually made it tightly coupled, that actually allowed to return and find an error, which is not an acceptable scenario for our business. Now, What can we do differently? So now look at this pattern, which is a microservices with event-driven pattern, where you can see the customer profile microservice is actually publishing some of the profile events. That means whenever a customer is being onboarded, your customer registered onto your website, there is a messaging platform. We spoke about the event broker. So the customer profile service publishes a message. And these messages are a standard definition of JSON payloads, very simple JSON payloads that will say, okay, this is the name of the customer, this is the date of birth of the customer. The customer review service actually gets a copy of that profile and have it locally available. Now, the customer review service in this case can actually, when a submission of a review happens, validate that age within the service and return error if it is less than 21. So it is loosely coupled here. It still has a dependency on the customer profile service, but it is not at the point of the user submitting the review. It already has got the copy. So imagine that user journey where they have come onto your website, they're done and sign up. So you got the profile data. Profile data is subscribed by customer review service and like so many other services in your ecosystem. And then the respective services will react to that event whenever that happens. And when a submission happens, it can use it for validation. And again, there are a few other principles of how much data redundancy you would create. All those principles probably we're not discussing today, but those are the topics that you could probably explore further and look at the best practices of doing an event-driven architecture of how you could publish these messages and subscribe these messages and use it in the respective services so that your services are isolated from other services being unavailable, but still has got that cohesiveness and they are operating independently. So probably I'll pause there and I'll take any questions if there are. The next 15 minutes probably we'll spend on serverless.
There doesn't seem to be a question right now.
Okay. So very niche topic, event-driven architecture is, and as I said, connect with me if you wanted to learn more about event-driven architecture. We have done a lot at IDP. And as I said, right, many organizations dream about being event-driven, data-driven, event-driven. So we have actually being one of the initial first adopters of these architectures. And when I talk about serverless as well, so I'll be happy to talk to you much in detail and a lot of techniques and methods that we could implement and how we actually do sessions like event storming, understanding from business perspective, how actually what events business are interested in, what events that they produce. We call them domain events. And also very simple, in simple terms, you would have been across clickstream events. So when you visit a website, whether it's IDP website or any other website, there is tracking of your user behavior, right? And how is the user behavior tracking happens is through the clickstream. So every page visit of yours is tracked, every clicks of yours is tracked, and that is how the behavior analytics is also being done. And you could be anonymous still with the device ID. We could identify who the user is. And then when you registered, you would get associated to the anonymous journey that you had. And then when you get onto a registered user, you could all link back all the sessions that you had, the pages, the clicks. And also we could use that for testing, like do some A/B testing to know where we're getting more traction around what services and features that we are deploying for our customers. The whole lot, right, with event-driven. So I would probably get you to take away that and explore a bit more on internet or on event-driven architecture. Okay, now let's jump on to serverless architecture. So we have seen microservices.
Srikanth, if I can interrupt before you start this topic, there's one question on what is the difference between event-driven and session-driven?
So session-driven probably is much more granular in terms of what happens within a session. And if you're talking, maybe the question could be related to a session that happens for a customer on a website or when they're interacting with any of the application, right? So the bounded context of that is within that session of that user, right? When we talk about event-driven, it could still be related to a customer. It could be related to anything that happens in the organization. So I've given you three different categorization of those events as such. So something that has happened. So within a session, whatever the interactions that the customer is doing could be recorded as an event. So a page visit in a session is an event for us. A click of a button is an event for us. A submission of an inquiry is an event for us, right? So any of that you do, there is something to be reacted for it. For example, you submit an inquiry, we wanted to send you a communication message back saying that one of our customer representative or executive would come back to you and reach out to you, right? Or an SMS. So that's when that happens, how are we going to react to it? So within a session, if that is the context that you're referring to or ask the question, there could be multiple events that can be triggered.
Thanks,
So that
Srikanth. One
answers.
more question. For each microservice, is it required to go for duplication services to ensure fault tolerance?
No, so that is where we are going to talk about serverless and the cloud services, right? And this is where you get some of these provided by these cloud providers natively by default. So there's no need for failover services or another backup service. But there would be reasons for you to take some backups, like when you talk about disaster recovery, and depending upon the type of service that you have got, the appetite of the organization, what the organization and type of business that you are in, you might need duplication or resilience where you might want to deploy it in more than one region, for example. So there are use cases when it comes to high availability and disaster recovery, you might want to do it, but generally not. So looking at our scale of our organization, we don't want to replicate them because that would add overheads and maintenance and cost, obviously. So everything comes with a cost, right? Irrespective of whether we say we are on the cloud, there is a cost associated. So you need to be cautious of whether you want to do that. Uh, not an usual practice or a general recommendation, but it depends on the type of organization you are in. Banking is a different game, right? And an education provider like IDP, this case, is a different thing. So look at the organization you are building the microservices for, and if it demands for it, there could be multi-regional deployment strategy that you might want to have for a disaster recovery or a business continuity plan that you might have. That answers?
Yes, Srikanth. Thank you.
So, okay, so talking about serverless architecture. So we've seen microservices architecture, we've seen event-driven architecture. So serverless architecture is largely talking about the components of how we deploy these microservices or the event-driven architecture patterns. And combined with the serverless components that we have got. And as a note, as I said earlier, I would be focusing on the serverless components that are provided by AWS in this presentation, but then there are equivalent services available in other cloud provider platforms like Azure and GCP if you want to go and explore further. And I'll quickly talk about different cloud services, assuming that there are a few other things that you would have explored in the past, but just keeping it very brief. There are three types of cloud services that you would see. One is a customer managed services. So these are EC2s, so elastic compute services. Like these are basically the boxes that you get, right? And when you're doing a migration of your workloads from an on-prem to cloud, this could be one of the first choice that you wanted to take the application without refactoring anything, put it onto the cloud. So you go and choose the EC2s as your option. And the self-managed databases, you might be already on Oracle, you might have licensed with Oracle. So you bring your license onto the cloud. So this could be first thing how you would actually do any migration from your on-premise into cloud. But then when you get into the next type of services, you get AWS to manage some of the services. That means they have got RDS, right? For databases, they've got Elasticsearch. These are more of a platform as a service. So AWS manages these services on your behalf, but you still have to manage some of the things like patching and other things by yourself. You need to schedule your snapshots, etc. So there is still overheads for you as an IT team to manage from an, even if you pick and choose AWS managed services. We talk about a bit in the next slide. But when it comes to serverless, this is completely function as a service, right? This is software as a service. You would have been hearing about SaaS platforms a lot. So each of these components that you see here, a few examples are, you might be hearing a lot around Lambdas, API gateways, SNS, which are topics, queues, SQS, Fargates. These are all serverless components. That means they're all pay-as-you-go components. And we took the, in the metaphor of a smart city, we took the analogy of a Diwali situation where you want to switch on the lights only when the darkness sets. So you don't have to switch it on for always, right? And that is where serverless is all about, right? You only react to something, and especially when you're doing prototyping or even large scale applications that we have got at IDP, we use serverless is our first go. And so we have got the cloud first and serverless first approach. However, we consciously choose the other components as required depending upon the workload. So in the order of preference, and in the order of generally how people adopt to cloud, it starts from customer managed services to AWS managed and then to serverless. And we're much into that mature journey of where we have got serverless adopted for majority of our architecture within our organization. So is there a question, Kavya?
No, Srikanth. There was one question earlier on BFF.
Okay.
Or the, yeah. Yes.
Okay. So can I talk about that when I talk to you
Yes,
on
you can finish this
cloud
topic
reference
maybe,
architecture?
and because
Yeah,
it
yeah.
goes back again to the first topic.
So I have one in the later slide as well, so I can
Okay,
probably connect on that.
sure.
So how are we tracking on time?
We are at 12:25, but if you can take 5-10 minutes more, it'll be better so that you don't leave out what you plan to.
Okay, okay, yeah, that works. I think we should be okay. Probably in the next 10 minutes we should be all.
Sure.
If there are not any major questions. So when talking about serverless components, right, this is where we get a lot of elasticity. That means we can handle varying loads without manual intervention. Think about in an customer managed service or a data center, or even within the cloud. If you choose to go with the customer managed service like the EC2s or the load balancers, where you'll have to define how much of compute and sizing that you would need, and you will be paying it for the time that you specified and for the type of resource that you have actually opted for. But whereas in serverless, you choose what you want, and you'll only be paying for whenever the traffic actually peaks, and you will not pay anything if there is no traffic at all. So even if we deployed even it for a website. So because you can predict to some extent, but there could be unpredicted volumes and traffic that you can hit onto your website. So it gives you that elasticity. As I said, just said cost efficiency, pay as you go model. And the pricing models have been so attractive these days that they charge you to the millisecond level. So they're not heavily charged, but again, a wrong usage and a wrong implementation could lead to heavy bills. So we need to be conscious of that fact. It's not that given granted for everything. So think about that. High availability. It has got built-in redundancy. The cloud providers gives you that guaranteed high availability. There are 99.119s of availability as well for some of the services, and there are 99.99s. So that means they're all really highly available services. Someone asked about, should I have an backup of my service? And it depends on what your need is. But if it is for an availability purpose, going with the serverless architecture gives it out of the box for you, the high availability. And as I'll show you the cloud reference architecture, how we wire up each of these components together. And when it comes to developer productivity, we focus only on writing the business logic and the code. And think about these of all the product organizations like us. We don't want to worry about a lot around infrastructure because that's not where we earn money, right? We earn money as we place students into the universities. And for us, getting those differentiating products out into the market for our students and the test takers is important and critical for us, not the underlying technology. So we want to give that infrastructure overheads onto the cloud provider, but our developers would be writing code that is what is differentiating us from the competition. Again, as we said, no operational or reduced operational overhead. You don't need to manage the servers, no patching, etc. Even in an AWS managed scenario, there is a bit of patching and other things that you'll have to manage. But with serverless, you don't have any of that. And very recent addition to this is there are offerings of serverless databases. That means you can scale up and scale down as your based on your workloads. So you don't have to always pay for, because databases are generally charged a lot, right, in any cloud model. So you get that option of doing, and think about like how startups does a lot of prototyping, right? And this is very great use case for startups. If they don't want any of this to be done, they can just shut it off, or they can just ignore it to be there, right? And as someone visits the site or someone accesses their application is when they're actually charged for. So works very well in those scenarios. And as similar to that, as I said, works beautifully well for enterprise grade applications like what we do at IDP. But again, to note, the best practices and implementation is very key. So just to touch base on an cloud shared responsibility model, if you look at on the left-hand side is a conventional AWS shared responsibility model. But on the right-hand side, if you look at, that is what serverless brings to you. So on the left-hand side, you can still see customer is responsible for operational system, the network, firewall configuration, the server-side encryption, network traffic, whole lot, right? But if you look at on the right-hand side, it minimizes all of those overheads. Everything is taken care by AWS in this case. And as I said, similar offerings available across other cloud platforms. All we do manage from a customer perspective, like customer is an organization in this case for AWS, like IDP in this case, customer data, and we are responsible for the platform applications and the identity and access management. Of course, we do authentication and authorization of who can access our applications, and whoever accesses the application, what data they can see is all within our responsibility. But every other overheads is taken care by AWS. So that's where it frees you up, and the resources that you onboard in your organization can focus on doing that differentiating products for your organization, not worrying a lot around the infrastructure. And I got few resources here, and very famous ones are S3 buckets. You could have heard about on AWS. It's very durable, comes up with 11 nines of availability, and it's an object storage. So without going much into detail, because this itself can be done in a bigger session, a longer session, but think about these, and if you want to go and explore a bit more as you see them. Lambdas is what we use for compute. So any application code is written in Lambda. So we write our Python code, our Next.js code for our websites is all written in Lambda. So there is no need for any frameworks or a platform code here. It has got direct integrations with many of the other AWS components. And we spoke about pay-as-you-go. It is built per millisecond and comes up with a lot of security and access management integrated in build. So very cool feature, that resource component, solution component that you can rely on. API gateways, again, extremely scalable. So if it was in a conventional and traditional model, there is so much of overheads and developer has to think about when they create an REST API. But here it's just few clicks, you're ready with enabling an API for your application or your microservices. Just a couple of them as we see, but there are many, and every day there are additions to the serverless components from AWS, which are all completely managed by AWS. So I'll just take 2 or 3 minutes to go through the cloud reference architecture. Is something very close to how many organizations does it, and a few of that references of how IDP does as well. And someone has asked about BFF. I'll touch base about BFF in this slide. So talking from, take it from the left-hand side, what you have got here is the client systems, your websites or mobile applications. And then we have split that into three parts. Now you see there is a front end. There is a backend for front end, which is BFF. And then there's a microservice. So this microservice, you can imagine this to be multiple services. For illustration purpose, there's one service being shown. And this is the composition. And all of the services that you see here are serverless components that we have used in this cloud reference architecture. There's no dependency lot on server, other than the databases is a choice. You could use thing over between a serverless and an instance-based database is not heavy or complex, doesn't involve much changes to your code. Depending upon your need, you can switch them, but otherwise they're all independently deployable components that you have got. So what we're talking about here is a front-end application and a website where you have got a Route 53 where your DNS is managed, your CloudFront, which is your content delivery network, is CDN, and then you have got your application code within a Lambda, and then everywhere you could see a WAF, which is web application firewall, which is your security protection. We also got a few other things like Shield Advanced. So protecting our infrastructure, our application is very key. So there are security, a lot of security emphasis on this diagram that you could see. And again, when we have got static assets like your images, your chunks, your CSS, etc., goes into the buckets. And then this backend for front end layer is actually a public facing API that you have got here, which this front end application interacts with. So what we do is our microservices are protected through a private API gateway. So if you see a private subnet here, that means this is not accessible generally from your public internet or from your browser directly. You cannot hit this API. It will restrict you. You can only hit this API from your browser. And then we have got authentication and authorization happening here to ensure that you are a genuine user who can actually access the data that is in the microservice and what is within the restricted subnet, which is within the database or the files that are in the S3 here. So the backend for front end actually gives you that ability to protect your backend microservices, and also you can use it for orchestration or manipulation of data. So for example, you have got dependency on two different microservices to get you some data back into the front end website. The backend for front end layer can actually talk to two different microservices and bring you the data, compile it, collate it together, and give you the response back to the front end website. So there are numerous benefits of using this pattern. However, there are few other architectural patterns that are coming up as well, right? And this is based on API gateways with REST API. There are also things like GraphQL that is available on some other services. Like for example, take CMS system that we have got here, which is Contentful, provides an GraphQL ability. So we talk directly to the content management system. There is no the PII data, personally identifiable information over here. It's just the content, the articles on the website. We connect directly from our front end to here. We don't go through the BFF. So we avoid some of these hops so that you look at this way where you get into a website, you have your anonymous users, like who doesn't register yet, and you got a registered user. So for anonymous users, there's a lot around content, and they need their access and the pages to come out really, really quick. And if that is all within a CMS system, then you can deliver that directly. Whereas when they register, and you're not talking about a specific user with their personal data, their transactions that you have got, which needs to be further protected. So there needs to be much more authentication and authorization happening across. That is where the data would be within these microservices. The BFF layer does that orchestration and acts between the front end and the microservice to bring the data, ensures that we validate and authorize that user, at every level. So from a zero trust perspective, the request is being evaluated whether it is coming from the right user and they have got access to the right data is done at BFF layer and also at the microservice layer. And we spoke about the event-driven architecture. So you could see some of the queues and topics within this composition of a microservice. This might be overwhelming if you look at this diagram, but I'll tell you this is very simple compared to what we generally build applications as one monolithic application. There are scenarios where you build one website with everything under one repository. This is actually breaking down. So this microservice, what happens in our case, we have got IDP website, IDP mobile apps. They all access same microservices. So when you talk about an omni-channel experience for your customer, a customer coming onto your website, having some interactions, transactions, and then getting onto a mobile app should be very seamless. So they don't have to register, they don't have to recreate all of their profile and their transactions, everything visible across because they're all within the microservices and they would work through their own BFFs accordingly. I'll take a pause here if there are any questions.
Sure.
And the BFF question is clarified probably.
Yeah, I think so. There's one more question. How will quantum computing change the landscape of serverless computing? I think you can also add your expertise on, latest AI tech and all that. So how do you think the future is going for cloud computing? If you can answer this.
Quantum computing is another very big, interesting topic. I don't know if we could cover anything of that in today's session, but things of, again, the art of possibilities, right? There's so much happening around. So we speak a lot around encryption, security, right? The hashing algorithms and encryption mechanisms that we have got. Quantum computing seems to be able to break that within few milliseconds. So a bit scary though, but a lot of possibilities of how we could use that in real time. But again, it all depends on the applications and the choices that you make depending upon the business, because technology in practicality, right? Technology exists for business and you need to look at what your business needs, what your organization is looking for, and how you could take some of the technology advancements to your organization and get your business to make that as a business idea and take it forward. Quantum computing obviously is very interesting topic, but I'm probably not well prepared to give you a lot of details around quantum computing today, but I can come back to you for another session for ask for this. But the possibilities are numerous.
Thanks, Srikanth. Any other questions? Please feel free to drop in right now or raise your hands. Srikanth can answer a couple of more questions. Thanks, Dr. Vijay.
Well, while we wait for other questions, I just wanted to know about IDP, what we do. And if you can collect your questions and ask me, that's absolutely fine. So this is very refreshed strategy that we have got. What is our purpose at IDP? And if many of you haven't been across what IDP does, our purpose is to transform lives through international education. So we are into student placement business, as well as IDP is also co-owner of IELTS examination along with Cambridge and British Council. So I've given those QR codes here if you are interested to scan and look at the IDP Live app. And if you also go into Play Store or App Store, you could also find IELTS by IDP apps as well. So predominantly for me, the purpose of working at IDP, I've been with IDP for 16 years now. And what drives me is whenever I come to work, right, whatever changes or whatever development or the technology that we implement, and that is going to help a student get placed into a university. And imagine for some of them, that's the first time someone in their family having an international education, and someone who then, it's not always about immigration, right? People who gets an international education come back to their countries, come back to their societies and change livings of their communities. And it's so powerful in that way. So that makes me continue to passionately work for IDP, and equally test takers, right, who take IELTS examinations to go abroad, and they wanted to make a dream career over there, and equally supporting the global community. So that's our purpose. And if there are any questions before we wrap it up, and this slide has got my contact details and then QR code for you to scan if you want to connect on LinkedIn.
I am also dropping your email in the chat, Srikanth. So I'm dropping our
Sure.
emails. In case anybody has any queries, please feel free to write to us. We can take it up further as well. I don't see any questions currently. So in case there are no other questions, we'll wrap up the session. Thank you so much for spending this extra time with us also, Srikanth. And we saw quite a good set of questions today's session. Thank you all the participants also for making this interactive as possible. And we'll have our next session in the same series on 18th, and the third and final session on 25th. In case through these sessions you have more requirements, you can please put it on the feedback form we just launched. We will also plan for another session if it is required. Thank you once again to everyone who has joined today.
Thank you all. Have a nice weekend.
Thanks a lot, Srikanth. You
Bye
too.
bye.